So first, I just want to remind what an included angle is. So if I have like a triangle, right? And I'm talking about these two sides, the included angle is the angle between them. So the included angle is between the two sides of whatever you're talking about. Okay, so what the Hinge theorem tells us is if I have two triangles and two sides are congruent between the two of them. So this side will be congruent to this side, and this side will be congruent to this side. Then we look at the angles. Okay, and this angle, that this is 43 degrees and this is 30 degrees, tells me something about the relationship of the third sides of these triangles. So the fact that angle A is greater than angle D tells me that BC is going to be greater than EF. And it's called the Hinge theorem because it's like, okay, you guys know what hinges are? Hinges are in doors and...
They're both the same color.
No.
I'm like, wait, what? Am I confusing myself?
No good. Okay, so a hinge, you know, hinge in a door, or like in this compass has a hinge, opens and closes. Okay, so I've got these hinges, and the lengths of these are the same size. Okay, so if I open this one to a short angle, this compass, and I connect the tip with a piece of string, that'd be the third side of the triangle. Same length, but I open it to a bigger angle, and the string that would connect the tops on these are going to be different lengths, correct? So that's what this theorem tells us, that basically if we open up the sides, the two sides that are the same length, and we open one side of them further than the other, then the third side is going to be longer in the bigger angle. So the bigger the angle, the longer the third side. So that's all this theorem tells us. Does that make sense? Yeah. So as long as two sides, and this is sort of, you remember how we had the side angle side for the triangle congruence? The two sides are the same, it's the angle in the middle that's the different, and that's why the triangles aren't the same size, because that angle opened up further in one than in the other, which made the third side longer. Okay, and the converse of the Hinge theorem is exactly like the Hinge theorem except backwards. The Hinge theorem tells me the bigger angle gives me the bigger side, so we go from angles to side. The converse tells me the bigger side gives me the bigger angle. So we have the same idea of congruent sides, congruent side, but then on this one, I look at the side over here, and that tells me something about the angles. So 12 is bigger than 8. So on this one, the fact that BC is greater than EF tells me that angle A is greater than angle D. So up here, angle A was bigger, gave me that BC was bigger. Down here, BC is bigger, that tells me angle A is bigger. Let's look at some examples. I have that, oops, wrong pen. WZ and YZ are the same length, because that's marked. And XZ is the same as itself, because it's its own line, and you're always the same as yourself. And then I look at the angles 51 and 55. That's going to go to that side. This is going to go to this side. So which angle is bigger, the 51 or the 55? 55, which means that this side, XY, is going to be bigger. So XY will be greater WX. Yeah. Here we have a trapezoid. These two lengths are the same. And then again, if you're yourself, you're the same as yourself. 3.6, oops, goes to this angle, and 3 goes to this angle. So FCD is this smaller angle here, or this angle right here. This is FCD. And then this angle is BFC. So which one is greater, BFC or FCD? BFC, yeah.
This is easier.
They can be completely separate. The first thing you want to do is identify the parts that are the same. So I have a 12 and a 12. And I have a 15 and a 15. And then in between those, I have a 72 and a 61. So which is bigger, JK or MQ? Yeah, JK.
Aren't they the same? They look the same.
In the picture they look the same, but this angle is 72.
Oh, I didn't see that.
Yeah, and this one's 61. So the pictures can be deceiving, I guess, is the key there. Here I have RS is 8, RV is 8, so those are the same. RT is the same as itself, and we're looking for that included angle, so I want to compare these two angles here. So which angle is bigger, SRT or VRT? VRT is bigger, yeah. Okay, so for this one, I'm going to erase the X because it's kind of in my way. And we'll just remember that this was an X right here. That's X. That dot right there. Okay, so this one is a little tricky. Okay, so first of all, I want to find out the angles BXA and DXA. So if I look at that, BXA is this angle and DXA is this angle, and I want to compare those. So I need to look at the 3's are the same, right? And then this is the same. So the 6 and the 8 are what I want to look at. So DXA is larger. Yeah. So if you want, you can just do this. BXA is less than DXA. You can cross out the and put in the less than. That's okay. Now, I want to talk about BC and DC. This line here is the same as itself, and these lines are the same. So in order to figure out the angles, or the lengths of the side, I need to know something about these angles. What do I know about these two angles here? They're the same. And then those two angles are the same. This angle is bigger than this angle, correct? That means that this angle is bigger than this angle, so which side is longer? Well, if this angle is larger than this one, that means this side is bigger, yeah. Does that make sense? You had to figure out which of these angles was bigger so you would know which of these angles was bigger. And once you know which of these angles is bigger, then you know which side is bigger. This 9 is kind of unnecessary. Does that help?
Yeah.
Okay. Here we've got actual measures. So RT is the same as itself, and RU and ST are the same as each other. So which angle here is going to be larger? Yeah, because it's 31 versus 30. So put that greater than right there. And then PQ and RQ. Yeah, PQ. See, not too bad. And which one's the last one? This one overlaps, right? And so what you have is this triangle and this triangle with this angle 2 thing overlapping. So if you have a picture like this, what I recommend is you go ahead and separate them. Now, this angle B is made up of angles 1 and 2. And this angle B is made up of angles 2 and 3. Okay? Well, angle 2 is the same in both of them. So pretty much I can just ignore angle 2 and compare angle 1 and 3. Does that make sense? Because that's what I want to know. I want to find out what are the comparisons between angle 1 and 3. So I can ignore angle 2 because it's the same in both. So it doesn't really affect anything. Does that make sense? At all? Yeah, since they both contain angle 2, I can ignore it and just compare angle 1 and 3 and ignore angle 2. Because it's the same in both, so it doesn't add or subtract anything, it's just there. So AC is less than DE. So if I say that's one line and that's 2 lines, to say that this is less than that, which angle is bigger, angle 1 or angle 3? Angle 3. So angle 1 is less than angle 3. And technically we should have these little measures out there. I keep forgetting those. But did that make sense? And you don't have to take the pictures apart if you don't want to. Just for me, I think it's nicer, but it's your personal preference.